I just bought this Milwaukee angle drill. It's a super hog. I got it for 50 bucks at a auction, and we don't know if it works or not. The cord is cut, so I've got another cord here. I'm gonna wire in to that end and see if it works, and we'll go from there. I'm just gonna take some wire strippers. Now, if this works, then we'll use this cord. Take this apart and use this cord to rewire up in here, so we'll have a new cord on it. And this is just a regular tool cord. You can buy these if you want. This one came off another tool. Okay, plug it in. See if it works. Nothing. Okay, I'm just going to check this, make sure we got power coming to this cord. Just got a standard voltmeter. Red in here, the red to the black and the white, the black to the white. And then you can see right there we've got 120 volts. So we got power going to there. Now we're gonna have to trace it, see if we got power coming up into here. So probably gonna have to take this apart. First thing I'm gonna do is I'm gonna check these brushes. As you can see, these square holes are one on each side. Just undo these bolts, these screws, and your brushes sit right behind here. We'll check those brushes, make sure they're good before we take this apart. Make sure your cord's unplugged, because the power, you can still have power up in here. So we'll just undo this and see what these brushes look like. Practically brand new, hasn't been run much, or somebody's replaced these brushes. You can see right there when I compress it, it couldn't go much more. So these are practically brand new brushes. Looks good, doesn't look burnt. So I would say we'll check the other side first, and then we'll go ahead and take this section off and check this switch, make sure we got power going to the switch, and then power going out of the switch when we push the switch. Okay, here's the brush on the other side. Exactly the same, good condition. So these only go back one way. You can see right here, right down in here, there's a little tab that the brush connects to, and so this black plastic slides in these slots. So you just push it back down, holds itself in place, and then put the cover back on. These Milwaukee drills are super powerful, and they hold up really, really well. Not much goes wrong with them. You do have a forward and reverse switch, so this is going to be another thing that's going to have to be checked to make sure we got power. They're probably going to go into here first, and then we'll go into the triggers. We're going to have to check all this, make sure this switch is good, and make sure the trigger's good. These right angle drills are mostly probably used by contractors and plumbers, so they can drill through the studs. We use these for our roller screeds. We build concrete roller screeds, and these are what power them. So next step, we'll go ahead and take this handle off. You can use the flathead screwdriver if you want. I'm going to get a Torx screwdriver, and we'll take it off with that. Okay, these are T20 Torx head bit, and you've got two here, one here, and two here. Undo those and this piece will pop off. Okay, you can see here, put the black on the white and the red on the black, and and you can see the voltmeter's got 120, so we know we got power there. So now if we go here, we should have power. Just make sure you don't touch these screws there. We should have power coming out of the switch. Push the switch, you can see the voltmeter got 120 coming out of the switch. So now you can see it's coming into the switch, out of the switch into here, but you got one going here, and you got your white going into here. So now we need to see if we got power. This one here should have power directly. And you can see, so we got power going into there. You can see that voltmeter. I push it. It's got 120. Okay, I pulled off this other red. I put this red back on. I pulled off this other red, and then we're going to see as this goes in if power comes back out when I pull the trigger to go to the reverse switch. Okay, so we're losing power. We're losing power inside here. So we're going to have to take this out, this off, and the armature out, and see where we're losing power. As power goes in here, should be coming out this bottom one into the reversal switch, and this is what causes us to go forward or backwards. So we're going to take this apart, pull that out, and see where we're losing power. Okay, these screws are T25. There's 4 of them, 2 here and 2 underneath. So I'll just take those off. I've got the drill unplugged. Maybe 2 shorter ones go on this underside, and 2 longer ones right there. You can see a rubber gasket between them to seal it off. So we're just going to pull this top gray piece off. And there's your armature right there. You can see that whole thing just pulls right out. And we got our brushes in there. We're going to take those brushes out. You can see down in there. So we'll pull the brushes back out, and then we'll see what's going on with our wiring here. Okay, I'm going to pull this field wire out, and we're going to test that to make sure that that's good, and that we're not losing our power, because this could be shorted. And one of the reasons these can short is running the drill too long, overheating, and it burns up these wires inside here. So this just slides out of here. I'll show you. Just grab hold of it and pull it. And if you can see down inside there, you can see those pins. There's 2 pins, one on this side, one on that side. And this field wire right here and right here slides into the pins, and our wiring from here comes up into these 2 pins, and that's what charges these coils. And by charging these coils, create a magnetic field that allows this to spin, or causes this armature to spin. So we're going to test these with the ohm meter. If it's shorted, we'll get nothing. It's like these wires have broken inside. So got 0.6 ohms on that one, 0.6 ohms on that one. Now let's test and see if it's shorted to the case. So we're just going to touch the wire on the terminals, and then touch the case, and we should have nothing. Just go around and do all 4. As you can see, we've got no short to the case. Okay, so to put this armature back in, it's got these guides right here. As you can see, you can't really screw it up. Just get it lined up and push it all the way in. That's locked back in place. Okay, here's our switch. Here's how we test it. So we got our red coming out of our switch, and if you go one way on the switch, you can see it works. Now if I flip it the other way, nothing. But if I go from the red, keep it in the white, go from the red to the other white, and you can see that works. So the power is coming in from the red, and then one switch will power this, and then the other switch, you can see when I turn it back the other way, nothing. So there's your forward and reverse. So I think we're getting power here. Okay, we're going to test the armature. So to test this, we're going to use the ohm meter set on 200, and then we're going to test each one of these directly apart from each other, 180 degrees. So what I'm going to do is start on this. You can see this first groove, big groove. I'm going to start right there and just work my way around. So these should be really close to these numbers. They all should be really close to the same. I've already gone around and done this. All of them are right around that 1.0. And the next test is to test two right next to each other. Same settings on the ohm meter. So once again, I'll start just above this one. And the reading should be close to the same. As you see, we go around, everything's really close. So, and then we can test these, each one of these to the metal down here, and make sure should be no continuity at all. Okay, I'm testing the ohms on this switch. No power coming in. So when we tested it before with power, it was showing power going through the switch. But now we test it with ohms. I'm still on the 200 setting. As you see, should go down to almost zero. So if I have it on the black and the red, no continuity, and then when I push the switch, you can see that I'm barely getting anything going through. So I think our switch might be burnt. And then I go down here to the whites, I test ohms on the whites, getting the same thing. Barely any readings. So I'm going to take this switch apart and see if the switch is burnt. Okay, there's 4 little tabs here, 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 here. I just take a little tiny flathead and just kind of push it under there and twist it just a little bit to release these tabs. So all this switch is doing is sliding. So we should be getting contact when the switch is pulled between these two and these two. So all we're doing is right here at the top, here, here, and down here, here, and here is where this switch makes contact. So I think we're burnt. It's hard to see in the light, but I think we're burnt on these little areas, these contact areas. And if you look at this switch here, you can see these areas right here are where it makes contact. So it just slides forward, makes contact with those contact areas. When you let off the switch, it slides backwards. And all it's doing is bridging these two together. So going from our power cord here and here over to this side, which adds power here, and I think that's where we're losing power, is these contacts could be burnt. So I'm going to take and clean those real good. Try with a little blade and see if I can scrape them clean, and then we'll see, put the switch back together and see if it's working or not. Okay, I just got a little Dremel tool, and I'm just going in here and cleaning it real lightly. It's really hard to see, but I've got this little helmet. Let's see if we can see this helmet. Works really good. It's got binoculars and a little flashlight. You can see little stuff like this, and it works really well having these little helmets for fixing small things like this. So I don't know if you'll be able to see this, but we'll try. Okay, I think we got it. So I got the switch put back together. I'm going to show you a test with the ohms. So if you watch the ohm meter and I pull the switch, pretty much to 0. And then we'll test the top one. Same thing, pretty much to 0 ohms. So I think our problem was the switch was burnt. So I've got it cleaned up. I'm going to put this back together and see if that's what it was. So it goes back together the same way we took it apart, and I'll just put a couple screws in just so I can test it. I'm not going to screw it all back together. Just flip that over. Slides right on, and you're ready to put your screws in. They're built exactly the same, so they can go on either side. Okay, so now that we're in here, if you remember, our cord was cut, so we're going to run a new cord. Well, this cord that I've got hooked up, we're going to run that up into here and put new ends right here and up here where the ground is, and we're going to connect a new cord going into here. But before we do that, I'm going to make sure that this works. So we'll plug it in, test the switch, and see if this works. It's one way. Reverse works both ways. So something simple is just a little bit of burnt on the contacts on the switch caused this thing not to work, and somebody just cut the cord and threw it in the junk bin. So it's actually, everything in there is in really good shape. The gears look good, the armature looked really good, the brushes are practically brand new. So I think something's happened to where it burned up the contacts on the switch. So this cost me $50 to buy. If you had to buy a cord, maybe another $5 for the cord, and then some time just to test it, fix it, and I mean, everything's in really good shape. The case, everything looks pretty much brand new. So this one probably could turn right around and sell it for $250. So in reality, you know, you're close to $200, a little under $200 profit on something like this. They sell for brand new for $400 to $450, and they sell refurbished for $250, $300. But the used are still up around $150 to $250, and that's the better the shape they're in, the more money they go for. So this was an easy fix. Some of them are a lot harder, but as you can see, it doesn't take much work, and all you need is a voltmeter, ohm meter, to test the different things. And these things are really simple and easy to fix, easy to test, and you can buy parts for all these. I mostly deal with Milwaukee's, these exact super hogs, these exact angle drills, or Makitas, which is exactly built almost exactly like this. They're a little bit smaller, they're not as powerful. I like the Milwaukee's better, but like I said, we just use these to use for our electric roller screeds in our concrete business. So we build them and sell them. And so easy fix. These are super popular. The battery powered ones are a little bit different, but as far as most of this is the same, is real similar. Anybody that's having problems with these, easy to test, easy to fix, and the parts aren't really that expensive. They're easy to find. I'll put this back together and we'll try it again, make sure everything's working. Okay, we're going to replace this cut cord on this Milwaukee drill. So I've got the handle completely taken off, as you can see right here. All we have to do is undo these two screws and slide this. This is the end of the cord. It'll slide right out, and then we'll just undo these. And here's our new cord. All we're going to do is we're going to cut this so all these wires are the same length. As you can see, the black one's longer than the white, and then the green's longer. So this cord came off a different drill, but we're going to go ahead and cut these so they're the exact same, and then everything should fit perfectly back inside the handle. And then we'll put these new ends on right here. We've got the new ends, same size. You can see those. We'll crimp those on, and I'll just pull that down, and then go ahead and get your green, measure that out because that's your longest wire. Get your green, and then you can figure out right here is where you want to take the cover, the casing off. So just use a little razor blade. Okay, now we line that back up. It's going to be our green, and then we want to cut our white and blacks to the same length as these. So for that, I don't know if you can see that, but then we'll just crimp that. In through, and you can see this rubber thing goes in, and it clamps right here, keeps this from moving. There it is, simple fix, new cord. Easy money. So I think anybody that's ever used a screwdriver or a voltmeter before can fix most of the issues with these things. Now if you see one that's in really bad shape, it's probably been used to heck and may not be worth fixing unless you can get it for hardly nothing. If these gears are wore out, it may not be worth fixing. But a lot of the electrical stuff, the last one I fixed had a bad armature, so I just bought a new armature. I think I bought it for 50 bucks and bought the armature for 40 off eBay, replaced it. It works great. So that should do it for this video.